right. Thank you, audience joining online, and Sina. Next up, we have Using AI to Place VMs on Hypervisors by Sina Kashipaza from LeaseWeb. Take it away, Sina.
Thanks. Hello, everyone. Thanks for being here. I'm Sina. Today I'm going to show you one of my side projects to place a VM on hypervisors. Speaking of myself, I'm a software engineer at LeaseWeb. Java and cloud and networking. Usually I was involved in this since last year of university, 5 years ago. And I found CloudStack, and it has both Java and the cloud stuff, and it was kind of cool to have both of them at the same platform. Since then, I was the software engineer at LeaseWeb and helped them maintain and develop the feature for the CloudStack. In LeaseWeb, we are providing service for the customers, infrastructure as a service. We are infrastructure as a service company. We have data center in multiple locations in the world and providing VPS to add resource pool to the customers. We also use CloudStack for our internal application to manage our services, test phases, production environment. For today, what was my initiative and targets? You see, the CloudStack uses the simple algorithm to place VM on a host. These algorithms sometimes are good, sometimes are bad, and we want a better management of the resource in the data center. And of course, decrease the cost of our maintenance, because sometimes even though we have a resource in our data center, CloudStack cannot place a VM on a host because, for example, it doesn't have any resources for 64 gigabytes of virtual machines. But overall, in our data center, there's plenty of the resource for the VM deployment. Because CloudStack places VM in a different way than what it's the optimal way. For that, I created a project that you can compare the different algorithms and see the result, and also develop some application and some other algorithm and a scoring system to compare them and see if one algorithm is good, but the algorithm is bad, how they compare, etc., etc. And before we start, I have to give a short hint about the AI. If you are not familiar with that, we have three types of the AI algorithm: supervised, unsupervised, and reinforcement learning. The problem with the CloudStack is that we cannot guarantee that something happened in the past happened in the next year. For example, we can have a promotion, the marketing add a promotion and we get a lot of VMs, but next year there is no promotion, and we cannot use those data to decide if it's a plan. and number of hosts, and everything changed because of the dynamic of the CloudStack. So we when I'm comparing the AI algorithm, I noticed that it's impossible to find a pattern in the past orders and say, okay, customers will use this pattern to order a VM, and then let's plan for it, because it's kind of rare to happen, because it has a lot of factor in it, like recession and everything can easily impact the number of the customers in the platform. So, but there is a category of the AI algorithm that they are not dependent on the past runtime of the system. They are online algorithm that they don't need to training phase. That they sample the current status of the environment, and then after that decide if it's good to, and then make a decision. So I get those algorithm because of its nature. It's better fit to our use case in the data center and working with that. Yeah. For simulation, I don't have a 10 data center to run my application there and then get a result. So I came up with an idea of creating simple host VMs and service offering at CloudStack and binding together and run the algorithm there. And then after simulation, I get a number of the VMs on a host and score them, a number of failed VMs, and see how they compare. For that reason, I didn't simulate all of the SEC features. Of course, 99% of them are unnecessary and they don't affect the placement of the VM. And I ignored some of them that also enforce some laws on placing VM like tags and etc. And I assume that they all have the same tags and they can place on any host on my simulation for simplicity. And I also added an evaluation system to see if compare the result and say, okay, this is the better algorithm, this is the worst algorithm, which one is the best one, and in which situation we should use that one, and etc. etc. And I also use the fuzzy function. Let me give a little bit hint about how the fuzzy works. Fuzzy system, fuzzy function, and fuzzy numbers, etc. used in environment that you want to describe something that is vague. For example, what should be the room temperature? Or that's dependent on the environment and everything. I calculate one fuzzy number, which is the capacity of the host and allocated resources for the host, and based on that number, I make a decision and place the VMs. So let's see the code. Sorry. Let's start here. There's a bunch of imports. And in here I describe the service offering. I later use this service offering to generate the VMs. And there's no ratio limit between this CPU count and the memory, because you are an admin, you can select every ratio, don't enforce anything, just for simplicity. And this is the host. Host can have some helper methods that calculate the free resources and allocated resources. It has a list of running VMs, memory, and CPU, and it can run VMs when CloudStack tell host to run a VM, it's check for its resource. If it has enough resource for the VM, then it's appended to this list and assume it's running, nothing running in the background. And this method used to calculate that fuzzy number we later on use to generate the state of the system. And this method is for the sources. I forgot to mention that I assume that all of the hosts has the same CPU speed. For simplicity, don't want to fall into that. And the over-provisioning factor is 1. This is, of course, not a physical hypervisor. There is no limit to add as much as CPU you want. If you want higher CPU, for example, if you have 16 core physical hypervisor, and you want over provisioning of 5, you can simply define your host that has 80 core. That's an over provisioning factor. And VM is just a placeholder that has a service offering. I didn't implement the usage because when we place a VM, we don't consider usage. And it's the placement calculated based on the allocated resource. But it's there for the later use. If you have any idea to how I can simulate the usage, please share. My idea was to place some process in this VM and run and then sample. For simplicity, I just drop it. And CloudStack, of course, has a policy to place VMs. We later on we will see how this policy used to place a VM. Number of hosts, these are our host-related arguments, and you can define anything you want. It's this variable used when I use fuzzy, and then it deploy the host. Nothing too interesting about it, and then deploy VM. In that, it picks the host in this method.
Sina, sorry to interrupt there. Can you increase the font size of the code?
Yeah, sure.
Thank you.
Is it better now? It selects the host. And if the host is none, it means that our algorithm couldn't find the appropriate host. It returns none, and it later on use this to detect if the VM deployment failed or not. And the magic happened here. It checks the current policy, and based on that, pick the host. CloudStack has list consume that selects the host that has not used this too much. And the first bit that picks the first host that you can find. And then method to implement those. And these are some helper methods. I skip those because of the time. And last but not least, these are the functions I used to plot the status of the system. You can see the result later. and also these two. Let's jump to the demo. If I run these, I import these functions and use some import that I didn't need. I define this service offering. For example, this one is, has IDs one CPU core and 2 GB of RAM. That's my consideration, and this is the service offering that I use for all of my plumbing simulations. Let's see what we can do. Now I created a CloudStack instance with the policy first fit, then host, and I use it to deploy 100 VMs and selected service offering randomly from this list. I can, if you see the state of the host 0, this is the VMs that are running in the host, memory core name, can change it to anything. This one is empty. No, it has also a lot of VMs. And I can get the host status, like for the host 0, it has 1 CPU free and 34 GB of RAM, free RAM. Number of allocated resources. But it's hard to read the data from these strings. For that, I created this chart. In this chart, it shows the nodes status, node 0, 1, 2, 3, 4 to 9, and the amount of RAM allocated to each service offering. And it's the current usage of the host. There's also a same chart for the CPU. The problem here is that, as you can see, there's a lot of big service offering in this simulation because I used the random choice between these two. I should use some distribution. For example, this one. This is the last service offering. In normal situation, in real world, we don't have as much as small VM, big VMs. So we want to enforce some policies that manage the number of VMs that we select randomly from the service offering. So I modified the previous code. You have it. You have both of them at the same time. This part run the same code with the applying that distribution, and then this one without the distribution, and then we compare the result. So without distribution, you see the number of the big VMs dropped dramatically, and the number of the small VM increased. It better simulate the real world. If we compare these two, you obviously see that those VMs, we have less VMs in our environment. And also for the CPU usage is less than, and number of VMs change. I noticed that it's better to have this distribution. Let's give and because there is somewhere here the number of the host is at the peak. Sorry, number of the VMs that use the service offering. If I run the same, get quite the same result as this one. So this was the showing the status of the system. Let's compare them and see which one wins. If in this example, I created 3 serverless examples, one with first fit policy, list consumed, and random, and then picked one service offering from that list with this distribution. That is, and then deployed 350 VMs there, and then plots the host status. As you can see, there isn't obvious difference between these. So let's make it smaller. Okay. The first fit policy selects the first host that it can find, but least consumed balance the data center better. It's better overall for a score. So we want to use our host as much as possible, but we don't want to leave these hosts empty. We want kind of balance between these two. And the random policy selects everything random. But the problem with the balanced feature is that if I increase the number of the VMs, let's repeat this example. You see here I have enough resource to create big VMs, but not on this one. You know, there isn't enough resource. And if I also plot the CPU status, you see the same pattern here. I can easily feel my biggest VM here, but none here. So that's the problem. For this experiment, I added a fuzzy policy. Let's see what it does. This is the first fit, least consumed, and fuzzy. It first tried to fill as much as possible and then balance the load between the hosts. If I change this variable to 5 and increase the number of the deployed VM, you can see the difference. You see in first fit, after 350 VM deployment, we are not yet used the node number 9. But in fuzzy, we get hell out of this first host and then balance the load between the remaining one. I can change the behavior of the system with this value, changing this value. But for now, I don't know which one is the better for me. Let's add some score to it. I will skip this one because of the time constraint. So I use the same. I repeat the same code to create CloudStack instances, but this time I count number of failed VM and calculate the score. The score is maximum memory. It has a correlation between memory and price. And if it failed to deploy the VM, this is the penalty that the application receives. It's a simple thing.
Sorry, Sina, you have 5 more minutes.
Yeah. This is the last one. And if I run this for 400 VMs, you see the number of failed VM. Least consumed failed VM is less than bigger. For overall, least consumed failed in less cases, but it get a lower score because it cannot, if it missed the 64 gigabyte of memory, there's no point to have a bunch of small VMs, maybe making more money out of that VM. So least consumed is not don't fail a lot, but it generates less revenue. But the fuzzy thing that I use is not as bad as the first fit, but in number of failed VMs, but it has the higher score than this one, and this repeats quite. I ran this experiment for 100 times and it was quite the same. And yeah, let's skip this one, but see the state of the system. Okay. And last thing that I want to mention is this alpha. I ran it for 100 times and get the alpha to see which one is better. Somewhere in the middle is the best alpha. You have not too much failed VM, but you have a higher score. And that was the presentation for today. If you want the codes or you reach me out, I will ping you. I'll send you an email and I put them in the GitHub. Yeah, that was it. Thanks for everyone.
Thank you, Sina, for the talk. We have a question online before we do that. Any questions from the audience? All right, Wei has a question.
Hi, Sina.
Hi, Wei.
Hi. So I have a question. You are talking about AI. So what is your data set to process, and what's the result, and what's it used in your code?
I generate the VMs online based on that distribution. I don't have any data set to infer based on that data set. I generate it's a kind of reinforcement learning. We don't have a data set. We kind of run the experiment and then calculate the score, and then make a decision based on that. So the important thing was that distribution and the generation of the VM, not the data set.
Awesome. Thank you, Sina. We have a question online. Is this work on a public GitHub repository?
I can share the code with you. I should make it like fancier and make it. add some
Awesome.
document to it. Yeah.
So the
Reach
online
me out.
audience can use the Hibulu platform and reach out to Sina directly if they have any questions or they need access to this repository. Thank you, Sina, for the talk and for your time, and the online audience and the audience in the conference. The next talk will be in 10 minutes. Let's give Sina a round of applause.
Thanks.